Alright, stat students, so let's do a quick little recap here. Okay, so first thing we need to talk about, the population. The entire group of individuals that we want information about. It could be anything. We talked about cars. It could be all the students at Cosby High School. It could be all the students in Virginia. It could be pretty much anything that we're interested in studying. So how can we get information about the population? First way, do a census. In a census, we attempt to contact every member of the population. The value that we get by asking the entire population is what we call parameter. That's a key word that you must know. And again, it's not always practical to try to contact everybody. Our United States does a census every 10 years. Okay, but it's difficult to get in touch with everybody. Think about it. You have to get in touch with all the homeless people, people without phones, people without houses, people that are dodging you. It's difficult to do. And that's one of the cons. It's time consuming, expensive, takes a lot of resources, and believe it or not, it's not always as accurate as you would think because of the difficulties that arise with doing a census. So if a census isn't our best way to go, what else can we do? And what we want to do is we want to take a sample from the population. It's a smaller group and it's easier to work with. The value calculated from a sample is a statistic. Again, that's that key definition. We got to be able to differentiate statistic and parameter. Alright, and there's my nice little sample of cars taken from the big population there. Alright, so we've got our different sampling methods that we have. And we talked about these before. Simple random sample, stratified random sample, cluster sample, and a systematic. So let's look at each one in an example. In a simple random sample, each different possible sample of the same size has an equal chance of being the one chosen. That's the key definition, and you are going to have to know that. So every group of the same size has the same chance of being chosen. Okay, how do we do this? Number every member in the sampling frame. Now the sampling frame is the people that you actually have the list of to take your sample from. Okay, so let's pretend that we're taking a sample of students from class. My sampling frame would be all the students that are in that class that day, because that's where I'd be taking my sample from. And my population, we could think, would be that entire class. Then we use a hat or a number table or a number generator to pick your sample and survey the members in your sample. So let's take a look at one. Here we go. We got a bunch of random people there. We assign them numbers, generate the random selections, and that's going to be who's in our sample. Now realize every group of 3 people here is equally likely. I could get the first 3 people, I could get the last 3 people, I could get the middle 3 in a sample. Okay, so that could happen. I could also, if we think of these little weird looking things as females, I could get 3 females in a sample. I could get 3 males in a sample. All are equally likely to happen. Key definition of simple random sample. Okay, next that we talked about, stratified random sample. When the population can be divided into non-overlapping subgroups, then we take an SRS from each of the strata. Remember, we want to break the population into strata that are homogeneous groups. Okay, homogeneous means each strata is the people inside it are as similar to one another as possible. Then we take a random sample from each subgroup, and then we combine these random samples to form our overall sample. Okay, so let's take a look at this one. We've got our list of clients. Notice we break it into our 3 strata: Caucasians, African American, and Hispanic American. Then what we do is we take a sample out of our Caucasians, sample out of African Americans, sample out of our Hispanic Americans, and that's going to give us our overall sample that we have. Now, it may not quite look like these are all Caucasians or African Americans or Hispanic, but each of these people in here would be all Hispanics. All the people here would be African American, and all would be Caucasian. And then we'd combine them together to be our random sample that we have. The nice part about this is it guarantees that you'd have some from each category that you're interested in studying, where a simple random sample doesn't guarantee that. Now also notice, this can't be a simple random sample. I have to have this many Caucasians, this many African Americans, and this many Hispanics in each sample. I couldn't have a sample of all Caucasians, which would be possible if this was a simple random sample. So not every group is equally likely. One more, we've got 3 different schools. We give everybody in the school a number, and we pick, thinking as each school being as similar as possible. And finally, one last one, we got the population of boys and girls. Break into our homogeneous strata, boys, girls, and then we take our sample from each. Again, notice I'm taking a sample of size 4. If it was a simple random sample, all possible samples of size 4 are equally likely, meaning I could get a sample of 4 girls, 4 boys, 3 girls and 1 boy. That could happen. But notice, in a stratified, I have to have 2 boys and 2 girls. So therefore, every group's not equally likely. I have to have 2 boys and 2 girls in each sample. Okay, next we talked about cluster. Select groups of individual clusters. Remember, the clusters are going to be heterogeneous, meaning they'll be well mixed, meaning that they'd have some of every type. And that's why we could just pick a couple clusters, because it's going to represent everybody. So what we do is we number the cluster, then we randomly select a number of clusters, and we get info from every unit in the cluster for the sample. That's the key part of the cluster. You survey everyone. This isn't a great example, but notice we got like 4 different cities. Notice how they're all heterogeneous. They have small buildings, tall buildings, all of them do. They're not all the same, but they're all pretty consistent with what they have. So I would number each cluster, and then we would pick our sample, pick one of these for instance, or 2, and then we'd survey every block in this. Alright, systematic. This one I left off the tape before. But what we do is we view the population as a list or a sequential arrangement. Then we randomly generate a number, and we pick every number that comes after that. So pretend you're coming into class. You're walking in sequentially in an order. So what I could do is I could randomly pick a number between 1 and 5. Let's say it's 4. So my number would be 4, and then I would take every 5th number after that. So I'd pick person 4, person 9, person 14, etc. We can see that right here. Who's going to the office? Notice they're in order, and what they did, the number that they came up with was 5, and then they took every 5th person after that. Okay, so that's how they worked that out. And the last one's a multi-stage combined cluster sample and SRS. We randomly select a cluster, an area, and then we take an SRS from each cluster. So you can see in this case, we have the United States, and we've broken it up into segments. The reason, maybe we have people that are working in those segments. Or, now think about it, if I'm working, let's say we're working out of South Dakota. I could have people just fly to these areas now to do my study. I don't have to send people like a random sample all the way across the country to different houses. So there's stage 2, we break it into segments. Stage 3, now we randomly pick households inside of there. And stage 4 is we randomly select the individuals. This one has 4 stages. It's a lot more than we'll be dealing with. Or here we go, breaking Shanghai into the different districts, urban, suburban, rural. And that step to me almost looks like a stratified sample, because you're saying you're breaking into similar groups, but then where it changes is that we pick the blocks or towns randomly selected from each district, and then we pick the houses. So that's where it gets a little bit more to be multi-stage. Alright, so what can go wrong by taking a sample? Well, if you pick another bad method, like a voluntary response, in which you just let people who choose themselves by responding. The problem with this, you usually only hear from people heated on the issue, either for or against. It doesn't represent everybody. You're just going to hear the people that are really adamant about it or really against it. Another bad method that we'd have is a convenience sample, where you pick a sample that you think works. You ask the nice people. You don't ask the scary looking people. You ask who you think wants to be in your study. And again, that's going to throw in what we call a bias in the study, another key word here. A bias is a method that the statistic systematically results in an estimate that differs from the parameter too high or too low. Alright, so that means that my sample, my statistic that I get from the sample, the value from the sample, will be off from what it should be. It might be overestimating or underestimating, and we'll get some practice with that. Okay, types of bias that I can get are from undercoverage. Undercoverage, your method leaves out a specific group of people. So let's say I'm doing a survey over the phone. Okay, so I'm going to call houses up and I'm going to ask them how they feel about the presidential debate going on. Well, I have undercoverage. I've just left out all people that don't have phones. So that's going to be an issue. Do the people without phones have an opinion? Yes. And so now I'm leaving out that group of people and might be throwing off or introducing some bias into my study. Non-response. This is where people choose not to respond to your survey. And this happens in almost every study. You try to do your best that you can to get out of it, but there's only so much you can do sometimes. Response bias. Different than non-response. Response bias is where people lie or do not tell the truth because maybe they have a bad memory, they forget, or they're embarrassed. Think if we're doing a study on drugs, and I'm going to have your parents ask you the questions. You might not be as honest as you might be with an anonymous person. All right, and the last one that we have would be a poorly worded question. Poorly worded question is going to lean or get you more focused on one type of solution than being clear and being unbiased with that. So poorly worded questions, again, are going to have. So that's all we have. If you want to go back and watch the video, feel free to watch it as many times as you'd like.